Alright, here's my, I fixed my problem. So in my previous video I showed that I had an issue with the ISR getting clogged, and I think that's still kind of what happened, but I think I was targeting the wrong spot for it. I just wasn't really clearing it. I think my problem was with the in function, but here it is, it works. There's my up counter, and then here's my down counter. Works just fine. And this is all, everything is in the state machine. All PIO programming. So in my code, I have here, it's the same code I had last time. I did get rid of a couple things. But down here, the only code I'm doing outside of the state machine is my initial setup, and then here just to see that I'm actually reading values from my pens to make sure that those are working. Nothing is getting put into the state machine other than what's been told to be put in the state machine through this. So I had to learn about this in base and in function pairing, and that's how I'm reading the two buttons that I have attached, is by using those. So notice that this is set to the first button that I set up, and just, I guess it, just like before, it kind of knows that there's a sequence to these, and realizes there's a second one after that. I don't know enough about this to really say for sure why that works and why it's able to see both of those pins, but okay, because I didn't have to do the ×4 like we did up here to recognize the other LEDs. I'm sure we'll touch on that at some point. Anyways, just to explain how my code works again, all I do is I read from my two buttons, so it's getting a constant 0, or it's getting a 1 if I press one button, or 2 if I press another button. And so what I did is once it reads that, this in function transfers it into the ISR. The ISR moves that, I'm moving that ISR into my X register, and then I'm using the jump triggers to kind of control, almost like if-then statements to control where we're going. So it simply reads that if it's a 0, we're going to jump to WR, which I just say is the wrap. The wrap is now handling a little bit more code than it was last time. Before I was just having it just immediately just jump back up. Now I figured out I needed this code here to finally clear the ISR. I was having problems where that I could not get this to work unless I was pushing and getting, and that was the only way I could find that would reset the ISR. I knew something was wrong with the ISR because I could get the LEDs to work if I held down the button before I started the program, but if I waited too long and it ran a couple cycles, it would just stop working. So something was happening to make it get kind of stopped up, and so I tried moving values into the ISR just with the move or the set thing, and it just was not working. It took digging into the documentation of the RP 2040, the giant PDF file. I believe it was like chapter 3.4.1. Oh, I'm sorry, 0.4, my bad. It actually details the in function, and well, it's not quite in the language that I'm used to seeing in like the libraries of the RP2. It was enough that it kind of gave me a clue as to where to go. Down at the bottom it said we could use null to shift the contents of the ISR, and so I'm going to shift the entire contents because I want it all gone. Alright, so that's my solution. This is what finally worked for me. Alright, so I'm doing that at the end of every wrap. This is just to help me slow the thing down, because for some reason by doing this it was really fast. So I'm adding in a little bit of a slowdown here, and then I'm wrapping back up to the original target. So that's what my wrap jump does. So whenever I jump there, that's what I'm doing. And so the way that I figured out what to do with each pin, if I pressed a button, I either got a 1 or a 2. So if it wasn't 0, we're going to immediately jump to, we're going to decrease 1 from X and then jump to J2. For J2, what we did is we just checked again. If after decreasing by 1 it was 0, we're going to do one function. So that was my increase function. To increase, well, we'll come back to the increase, because the increase is actually harder than the decrease. So if there was still a value left over, then I decrement again and I jump to the decrease function. So the decrease is just the simple program that we talked about in lesson 90. I am going to use the decrease jump again, but just immediately go to the next line, and that way I can take y, which was the value I was pushing to my pins to light them up, and simply just decrease 1 from it. And that way I have my decrease counter. Just a little bit of delay there to slow that down. And then I jump to the wrap where I did all that nonsense that I told you about before, and then we go back to the top. The increase function works very similar in that, but I had to do some scratch paper where I kind of figured this out. To increase, I basically started with the invert of y. So I took y, whatever it was, I inverted it, I put it into y. Then I decreased, because that's the only thing we can do. We can only decrease. We can't do a +1, right? So I took the invert of it, decreased from the invert, immediately jumped down to the next line, and then inverted again. And the result of that is actually adding 1 instead of decreasing 1. That's crazy. I had to do a couple little binary tests just to prove that to myself. So that's the whole code right there. After that, we push to the pins, and then we jump and we start all over again. So again, nothing going on down here. Just some little information for me to make sure that my stuff's live, and that's it. It works. Pure state machine code, nothing else. I did it. It was all because of this little guy right here. That was the main thing holding me back. Just could not figure out how to empty that ISR. Alright, that's it.